everyone. I am Gargi Thipase, currently working as an IoT intern at Immertex Information Technologies. During my internship, I have been gaining hands-on experience in embedded systems, IoT technologies, and real-world project development. This presentation will walk you through my journey, covering my learning objectives, technical skills, project work, and key takeaways from the internship. Day 1. Day 1 was also taught to us with the introduction to basic C programming and its structure. C is general purpose programming language, was developed by Dennis Ritchie in 1972 at Bell Labs. It is the base of many modern languages like C++, Java and Python. C is known as structured, mid-level and compiled language. Programs in C are written using functions, which makes it easier to understand and maintain. The features of C are very simple, efficient. It is also fast executable programming language. It is portable, that it runs on any platform, supports pointers and dynamic memory, rich library of functions. What are data types? It is the basic type that tells the compiler what type of data a variable can hold. Mainly divided into three types: int, float, char. So int that stores 2 to 4 bytes, float that stores decimal numbers 4 bytes, char stores single characters 1 byte. Derived data types. These are the arrays, pointers, structures, unions. And user-defined data types are typedef, enum, struct. Number systems. There are many 4 number systems in programming: binary, octal, decimal, hexadecimal. All the data in the memory is stored as binary, that we all know, that is zeros and ones. Each bit represents a small part of data. Modifiers are used to change the size or type of the data that a variable can hold. Common modifiers are short, long, signed, unsigned. Day 2. Decision making and looping. Sign modifiers and conditional control statements. So what are sign modifiers? It is basically that decides whether a variable can store negative values or not. Sign that stores both positive and negative numbers. Unsigned stores only positive numbers. What is conditioning statements? We can also call it as if and its family, used for decision making. If statement, if else statements, else if ladder and nested if statements. And also we have switch case, that is used for multi-way branching based on single expression. Switch has a choice and it has cases and a default statement and a break statement to break up the cases. Now, loops. Loops are used to execute a block of code repeatedly. That means one statement to be printed for 100 times, then we use loops instead of printing or typing it in the code itself. Jumping statements are break, continue, go to and return. Day 3 was arrays and operators. Arrays is a collection of similar data items stored in the continuous memory. Types of arrays are one-dimensional, two-dimensional and multi-dimensional. Operators are arithmetic, relational, logical, assignment, ternary and bitwise. Overflow and underflow. Overflow happens when value exceeds max limit of data type. Underflow when value goes below. Day 4 and 5. Functions and pointers. Functions is a block of code that performs a specific task, helps in code reusability and clarity. So the types of functions are library functions such as printf, scanf statements, user-defined functions such as we have to bring a syntax over it, where we can return function name and in bracket parameters. What is pointer? A pointer is a variable that stores the memory address of another variable. We have asterisk pointer where that holds the value at address, and ampersand a where stores address of variable. Now, what is memory strings, memory statements, and the preprocessor? Null pointer is that points to nothing. For example, int asterisk pointer p is equals to null, semicolon. While pointer, pointer declared but not initialized, that contains the garbage address. Const pointer, a pointer whose value cannot be changed once assigned. Strings, collection of other characters ending with a null character. So there are memory segments such as stack segment, heap segment, data segment, and code segment. What is stack? Stack that stores the local variables. Heap that stores dynamically allocated memory. Data that stores global or static variables. And code that stores program code. Now what are preprocessor directories? They define the scope, lifetime, and visibility of variables. Hash include used to include the header files. Hash define used to define the constants or macros. And if and def that checks if not defined. Now, day 8 and 9 were for C++ and object-oriented concepts. In this introduction to C++, how it is object-oriented and also procedural, and the comparison with the C. C++ is an extension of C developed by Jarnes Tostrup in 1983. It supports both procedural and object-oriented programming. C focuses on function and C++ focuses on objects. C has no data hiding, whereas C++ has data hiding concept that is also called as abstraction. C uses top-down approach and C++ uses bottom-up approach. C versus C++. Here, C++ supports classes, objects, inheritance, polymorphism that are all called as OOP concepts. C does not support that OOP features. There are also called as access specifiers. These access specifiers are public, private, and protected. Public means when a variable is declared globally, then that variable can be accessed throughout the program. Private, when the variable is declared into a specific class, only that specific class has its access. Protected, accessible in derived class. What are derived classes? Derived classes are the classes that is being derived from its base class. Constructors and destructors. Constructor is a special function with the same name as a class, automatically called when object is created. And destructor is the opposite of constructor, that is used to free up the resources, automatically called when the object goes out of the scope. There are this encapsulation, abstraction, inheritance, and polymorphism is called as pillars of OOPs concepts. Encapsulation means wrapping data and function together. Abstraction means hiding implementation details. Inheritance means driving new class from existing one. Polymorphism means same function behaving differently. What is function overloading and function overriding? Same function name with different parameters. and function overriding is redefining its base class function in derived class. Now, here we have started with the introduction to IoT, Arduino and the project implementation parts. IoT means connecting everyday physical devices to the internet so that they can send and receive the data. These devices can be sensors, actuators, home appliances, vehicles, etc. The goal of IoT is to make systems smart and automatic without human interference. For example, smart lights that turn on automatically when it's dark, or fitness bands that send your heart rate to your phone. For example, the handwatch. Overview of IoT system layers: sensing, processing, cloud control. As IoT is an embedded system where the hardware and also the software is connected together to build or to make something real world. The sensing is the sensors and the actuators that take the data from the real world. Processing, that is the filtered data or the noise data gets removed. Cloud, this is used for storage, and control, where the software system controls the data and also sends output. Arduino board introduction and pin configuration. Introduction to IoT using Blynk Cloud and setting up Arduino IDE and Blynk app environment. We have downloaded this Blynk app into a mobile phone to also get the control over the sensors and through the simulator. Now, what are the applications of IoT? The smartphones, smart cities are also the applications of IoT, and the advantages is it time saves, energy saving, and real-time data monitoring. So basically, an embedded system is a combination of hardware and software designed to perform a specific task. The components are only two: hardware and software. There are also microprocessors and microcontrollers to control over this hardware. Examples of microcontrollers are Arduino Uno, Raspberry Pi. Now, what is this LED sensor CLCD? LEDs are basically a light emitting diode, is the simplest output device in embedded systems. It glows when the current passes through it in forward direction. LED has the long leg and the short leg, that is the anode and the cathode respectively. What is CLCD? CLCD means character liquid crystal display, commonly the 16 into 2 LCD. It can display characters, numbers and messages on the screen. It has 16 pins in total. Connection, that connect LCD data pins to Arduino digital pins. It is used for showing messages, sensor data or device status. Temperature sensor. Temperature sensor measures heat and convert it into electrical signals. Applications are smart weather stations, room temperature monitoring and greenhouse control. Now, serial tank. Serial tank implementation means the serial tank experiments use the serial monitor to display sensor readings like water level or analog sensor. Data is sent from microcontroller to the computer using UART communication. There are serial ports that connect, that is a serial communication syntax, that is serial.begin in bracket 9 600 semicolon that starts the serial communication and serial.print that sends data to serial monitor. We will see that into the project implementation. Right. Then we have hands-on simulation using PixSimLab. This is a virtual simulator that helps into gaining the practical hands-on experience for the project implementation. What is Blynk app? This is an IoT platform that allows us to control and monitor hardware using a smartphone. Understanding pulse width modulation containing LED brightness and motor speeds, using analog sensors for temperature and light detection, code implementation for analog write and signal modulation, debugging and observing sensor behavior in simulation. Arduino project implementation. This project was basically divided into 4 parts where the Blynk integration was also made, setup of Blynk cloud and template creation using authentication tokens to connect Arduino to Blynk, virtual pin communication between cloud and hardware, LED temperature and water level control using app widgets, final integration, home automation using Arduino plus Blynk. System tested using Ethernet model and simulation tools. Final outcome and learning summary. This internship helped me during strengthening my programming knowledge base to C and C++, mastered hardware interfacing and embedded communication, successfully implemented a real-time IoT system, understood the complete cycle code, hardware and cloud control, gained practical debugging and problem-solving experience, prepared for industry-level embedded and IoT projects. Outputs of my project implementation. This is the CLCD, the control over it, the cooler, this is the LDR and the LED. The LDR actually has the control over the LED and this is the temperature that is being shown. This is the simple Hello World program that was shown on the CLCD, working with it, where I have printed Hello World and also I have printed over here Gargi, my name. Then this is the serial tank where I have connected my ports COM1 and COM2, and when I click on connect and disconnect, the water level gets filled and it also gets empty. It has some inlet valve, outlet valve, and based upon the temperature given in the program code, it gets filled. This is the simple garden light example that I have made. It's a garden light sensor. This is the last part of the project, but I will also bring up a simulator and show working. So hereby I end my presentation and see the simulator working. Thank you. Now we will see some of my codes that I have been implemented. serial time.h, temperature system and temperature system.h, and it has a main file where all the virtual things are being defined, and according to this we take it, and also we include the header files over here, and this is my token ID, Blynk template ID, template name, the authorization token. This all files that I have been included, the main.h, system.h. This is the main INO file. The liquid crystal display, that is the display screen that we have seen. This is the inflow on, inflow off that I have printed. Now I will show you the CLCD. This is the CLCD code. Where hello world and Matthew is being printed. And we have seen in the output of the PPT. This is the LDR and this is the serial time. You select the board over here and you select some ports. If you don't get the ports over here, you have tools, you have ports, and you can select it over here. Now I have selected at COM5 and COM6. The serial write and the serial write is a function that actually helps to enable the inlet valve. Okay, we can set the cursor where we want to print on the LCD, and we have the serial available functions. Then we have defined this, and we have liquid crystal display to display the outputs of the serial time. So yes, this is my course. And these are my outputs. Thank you. This is a pixel lab simulator where I have been taken up with CLCD, that is the temperature, it has the volume, and it has the serial time that now is connected with the ports, and now I have been showing you with the serial time where I could actually make the LED. This is the LDR, this is the cooler, and now your serial time water gets filled. Here we have actually displayed inflow of, this is the LED, and with the help of LDR I can control it. The LDR is on. This is the Blynk tab. The dot over it actually shows if the device is offline or online. When this LED gets off, the Arduino gets on, and here this is the temperature that is being seen over on the CLCD itself, that is 27.34, and on the heater the temperature starts increasing. You can see that is now become to 34.18. Heater off when it starts decreasing. Then I start the cooler on. The cooler on makes the temperature again to normalize, that is 27.32.